Am I audible? Dear friends, am I audible?
Yes, sir, you are audible.
I am audible. Right. So we will get back to that video render class. Yeah. So now we will see a hello world code in quantum computing. So these first few lines are very pretty straightforward. Right. So what we are doing to simulate the behavior of quantum. So we are calling a function called random bit. So what it provides, it will provide values randomly. So that will be holded in random bit. So we are having two values, 0 and 1. So randomly generating values for qubit 0 and qubit 1. So don't worry, this is not pure quantum code as of now. It is hello world to see how it differs. So we are trying to generate 1000 random bits. Among 1000 random bits, how many are going to be 0 state and how many are going to be state 1? So end of main, this is sample code. So what is here? Here we are having in 0 and 1 variable, we are having the values of 0 and 1. 0 and values will be holded. So in classical computing, and two values at a time is not possible. So this is from what? Strange package only. Algorithm classic. To simulate classic, we are having under arg.readfx strange. So there I have a question called what is that? Strange fx. It is a package. Strange fx is a package belongs to Java. So with the help of that only we will carry out quantum programming. That is strange. Right. So in sample code. Now Pauli. So right. Now take a look at here. What is step one? Step one, we need to simply instantiate quantum execution environment. Then we need to create object of program. So what is happening now? If you provide the numbers here, based on the number, qubits are initialized. 2 qubits. So with the help of step object, step.add gate. So add about get sample program. New program. We are for that we are having 1 qubit. And there is step dot add gate. We are instantiating add mode object. Program that add step 1. And with the help of the execution environment, e dot then result execution environment dot run. In the starting slide, I have named it as simulator, but here I have named it differently, execution environment dot run program result dot get qubits. We are getting qubits. So this is in Java called for each loop. So this is a current type and this is a destination type. So that is the syntax for each. So inside qubit, what will be there? Two states, linear combination of state 0 and state 1 will be there. Yeah. So this is when we visualize, we will get Hadamard gate state 0 is going to be 50% and 1 will be going to be 50%. So renderer dot render program takes program type object. So this will be printed as output circuit. Then implementation sample code of CNUT. See, don't worry, I will be going through this code, but we will see line by line explanation of the code in the Eclipse. So step, with the help of step, we are having the CNUT C naught. So because for convention I have written C naught. Add gate, C naught gate we are writing. So look at here. Yeah, here. Look at here. There. This is the reason why C naught is what? Multiple qubit gate. So first is control qubit. The second one is target qubit. So likewise, we have added, and with the help of environment, we need to execute result and the program visualize. Look at here, execution environment dot run program. It takes input type program. Yeah, at the output after the program execution, finally we will end up with the quantum circuit. I told you, right? You remember combination of Hadamard and control not get yields entanglement. Pauli and not is the circuit of C naught, Q naught and Q1 on. So this is for control is going to be state 0. There is no flip in the output. Now C naught when control qubit is going to be 1. Same code. Look at here. You may think I have given 0, 1, but what is a simple change? We have applied Pauli X. Look at here. What we have done before changing the value, what we have done, input state will be given to Pauli X. Then what will happen? Pauli will invert the what? Control qubits value. So that's why we have not done any change here. Now this will become 1, 1 comma 1. Right. So the process same. Now this is the gate for when control qubit is going to be 1. Look at here 1, and what is happening? Usually it will be replicate the same, right? But it is 1. Look at here, it is flipped to 0. Yes. This is what the truth table for C naught gate. So here there won't be any changes because why? When control bits are going to be state 0 0, there won't be any change in the target. Whatever it is in the target remains unchanged. Look at the entire compartment and look at this compartment. Same. Look at here. When control bit is going to be 1, then what is the corresponding? Whatever the target bit is there, that will be simply flipped. So it will become 1. So while running the code, we will see this target flipping. So then we have a small application in superposition. What is happening? Say this procedure is same program step, and we are adding gate, and we are processing this operation, instantiating qubits. So what I am doing in this program, I am tossing coins simultaneously. So 10,000 experiment, 10,000 events are happening. In the 10,000, what how to construct gate and apply superposition, measuring the probability, like in QKD, one application using this range, how we are implementing QKD, quantum key distribution. So Alice side and Bob side. So key will be distributed from sender and receiver, right? Sender will be Alice, receiver Bob. Snippet for Alice side. Quantum key distribution for receiver. Here, this is what matters. Circuit responsible circuit. Then only it is a valid quantum computing process. So reference Quantum Computing in Action by John was Manning publication. Is Calvin, Mahendra, Vishal, Shankar. Yeah, so this is all about the PPT having conduct. Yeah, you people are able to see here, right? So where the first very important creating Maven project step is very important, and where you will make mistake, that mistake will leads to multiple errors, etc. So what is step one? New other EROJACT. I think in prerequisites I was given. So we need to find the project type Maven. Click Maven. Simply follow me here. Here only QUICKSRT. This step is very important. Untick this box. It should show all versions of archetypes. It should show what? It should show. I think if you have gone through the prerequisites, there is something will be written. So that will be displayed here. We need to pick quick start. Which quick start? So that is very important. So let me show you. It will take time. So it if in order to reflect in this will take time. So I will show it from the screenshot. Look at here. We need to select Maven-archetype quick start version 1.0 from. This is very important. org.apache.maven.archetypes. It should be same. Maven archetype quick start. From which, this is our artifact from which company, from which URL, org.apache maven archetype. So then only Maven project. See, look at here. I got. So then only what is possible. So look at here. Group ID example in dot anu thantra artifact ID QTC-03 ZERO THREE. See, I told you, right? Snapshot is important. So first time, first version. So 1.0. Finish. See, if it is successful, then only it will create. Look at here. Now only this is successful. If you select everything proper, it is successful. Let me show through magnifier. Then there is one more thing to be. What is the thing I have given? QTC-03. So we are having multiple items here. Look at here. So form.xml. Here only we need to configure. So then let me open. So you are able to see from your side, right? Here only we need to add dependencies should be added here. Plugin should be added here. This form.xml file from your site. So now let me open from my project. So first QC. Yeah, look at here. Dependencies from here to here, here to here. Then build to build. Copy simply build to build. So this is the very important step while creating a Maven project. Right. So form dot creation. Then after that, look at here. We'll explain through magnifier. We need to create all those things under src main. So in this folder only, based on your project. under SRC main Java com QC action. Here only you need to create all your .java files. Right. This is another checkpoint. One is archetype selection from which company. That is the checkpoint. And where we need to create file, all the files under SRC folder. Form.xml and SRC. Now we will go to hello world program. See simple. This is to show what is happening in classical bit and quantum bit. So let me run. First quantum program I will explain you line by line using high level strange API to generate random bit which can be 0 or 1. Result 1 generated 1000 bits, 495 of them were 0 and 505 were 1. See why I am showing this? In classical environment this is not possible. This is from algorithm.classic. We are simulating classical computer from quantum simulator. So look at the arg.readfx. This is the import statement to have output from this. Let me remove this. What will happen? It will not be supported. This class will not be. So this is for classic, but it is from strange package. Inside quantum simulator, we are trying to mimic classical computer. The sample code is a simple conditional part. The only thing is what? In order to have this random bit, we need classic, this line. So in order to have this line supported, this import statement. So this is what? Readfx strange. Readfx strange. Right. Now we will move into SRC. Now we will go to Pauli gate. Yeah. So this code we will examine line by line. You just please take a line. Sorry. You please take a look. Let me explain one by one. So with help, with your permission, right? Let me have a cup of tea. So please take a look. In short, I will get back. Yeah. The code is visible. My code is visible. Right. So yes. Now look at the line number 17. This is the. So what is happening in line number 17? We are calling what? Simple quantum execution environment, and this is constructor. We are calling the constructor of simple quantum execution environment. Along with the new keyword, we are obtaining what? Object of the execution environment. So I am naming as of now as simulator. Now calling the constructor of program class takes argument of integer. So I am providing number 2 means what? There is 2 qubits are there. There is 2. If it is 1, 1 qubit. If it is 2, 2 qubits. Environment program, then it is step. Step is 0 argument. We are not providing any values to this. New step constructor returns step instance. Right. So what we are speaking, we are going to implement Hadamard gate. Sorry, Pauli. In order to add gate, what is mandatory? Step instance is mandatory. Without step instance, adding a gate is not possible. So there is Pauli gates x, y, z. So x simply flips, z also flips, but z flips in a different way, x flips in a different way. So added Pauli x, added Pauli z. So let me clear the console. So here output will get in the console. Now I got back. Yeah, right now we are at the step QEE program step. Right now we have added the gate. We have added the gate Pauli X and Pauli Z. Right. So how we are adding step? In order to add step, what is required? Adding step program object is required. So program dot add step. So we need to perform operation, right? So performing operation is step. With the help of program instance, we are performing operation. So add get Pauli X is then Pauli Z is done. Then program dot add step. Whatever step is performed, program dot add step. We are providing step as argument. Then results. Simulator dot run program. So in this program, QE is going to be simulator. Run program is a function belongs to. Let me type and so simulator dot. So look at here, run program function simulator dot run program. Control A, Control Shift F. Right. It takes of type program. So whatever the business logic available inside the program, now available with result. Now with help of result dot get qubits. In P, in PPT we have seen in order to avail those qubits, result dot qubits. I will show you type res result dot get qubits. Result dot. So get qubit functions will return qubits. Now we are having the qubits. Okay, now with the help of this variable qubits, we need to name qubits 0, first qubit, qubits of type 0, first qubit 0 of type, this is of type qubit. Then what we are doing again in this line, qubits, and I am giving the value 1, qubit, 0th qubit, first qubit, and I name it as 1. Right now we have acquired qubit also. Next what is should be done? With the help of qubit instance, 0 dot measure. What is it? 0 dot MEAS measure. So measure is to do what? To carry out whatever is there inside that. So that is with the help of measure function. With along with qubit instance, 0 dot measure. Whatever is there inside that, that will be stored in value. Then we have two qubits, 0 qubit and 1, 0 dot measure, 1 dot measure. Now look at here, whatever it is there inside the qubit, that will be embedded. So what is there in the value? The value of Pauli X is value. The value of Pauli Z is value 1. Pretty simple. This is the beauty, renderer. So either we can instantiate or straight away we can have. So to visualize the circuit, render is the constructor of the class renderer, new keyword and renderer. So and I told you right, renderer contains which function? renderer, renderer dot render is having what? So it will display render program is there. So with the help of render program takes what type? Everything we do in this program available is inside the program. So that is decoded. Look at here. In order to have the better accessibility, return a simple SOP statement. Pauli begins, the Pauli ends. End of main method ends here, and our class ends here. So in console there is nothing. Now let me run as Java application. The beauty, let me see the circuit later. Look at here. To confirm all the code is running. Pauli begins, Pauli ends. The value of Pauli x is 1. Right? We flipped once 0. In the Pauli x we had what? 0. Now it is showing 1. Pauli z is what? It is rotated twice. So that is the value of Pauli z is 0. See from where it is coming. In order to show the circuit, look at here. This is the circuit. On x, 0 is given, 1 is outed, and again 0 is given, 2 times rotated, again it ends with what? 0. So this is the beauty of renderer. So render only visualize the circuit. So how to write QC code? Quantum execution environment, program, step, then which gate operation that is done, then after gate operation step will be given to program, then we need to acquire qubit, from qubit we should measure. So this is here a program for single qubit. Right, now we will move into Hadamard gate. Same procedure, there is a slight difference because Pauli simply flipped. Whatever is given, that is flipped. We cannot able to have multiple states, right? So in order to demonstrate that, we need, and one more thing regarding the import statement in Pauli. Look at this. This is a difference. It is purely quantum. In normal Java programming, you cannot have these kind of import statements. This is the import statement for this program. The required import statements. Import dot arg dot redeffect strange dot program is a class. Right, now we will see header mod. So main to main. So let me include one more. My typical style will include begins and where main method ends. The main is here. So, sir, I will get back to you after 4:30. I have a meeting. Yeah, begins and main method main ends here. So this is to ensure. Okay, it is not mandatory. It's to ensure. It ends. So yeah, right. So now if you run the code, it will show us begin as well as ends. Right. So as usual, program step. Yeah, what is the change? Instead Pauli, we are adding Hadamard. Instead Pauli, we are adding Hadamard. Program dot add step. Again the same process repeated. QUE run program get qubits and write. So there in previous program we have not used this type. So for each, in order to retrieve the information from qubit, you can use for each loop also. This is current type information is qubit. We need to upcast it to type qubit and of type qubit. So inside qubit, what is the values are there? Qubit dot get probability and the qubit dot get probability. So it is what this, and this is also available in core Java and strange package. In normal Java, in Java programming, normal APIs will not support this. This is possible in only strange. Then as usual, renderer dot render program will print the circuit. So what is the beauty of Hadamard? Equal superposition. What is that? Equal superposition. Right. Let me clear expected output. What is the expected output for this? Look at here. Begins, ends. Yes, our code runs end to end. Qubit probability of state 0 is 499. Qubit probability of state 1 is 0.99. And where is our renderer? Our renderer is the Hadamard magnifier. This Q0 applied Hadamard. 50% of 0 and 50% of 1 is there. Right, Hadamard. So we have seen a single qubit as well as in a single qubit we have seen Pauli and Hadamard. We will increase the complexity of code little bit. We will move into multiple qubit. I think now you will tell. I think you can follow me again. What same process? Now we are having what multiple qubits. So we need to provide two. We need two qubits. Program initializing two qubit step. So I have written C naught step. C naught. First one is what? Control qubit. Second one is target. So what we are trying to do? We are providing what? State 0. Control gate is having state 0. And the program dot add step. Execution environment. Then execution environment dot run program. Takes type result. Then with the help of result we are getting qubits. Qubits. See later we have named qubits 0 and 1 I have given. Do you remember? So now instead that we are exploring the entire qubit. We are exploring the entire qubit. Qubit dot measure. Qubit dot get probability. In order to see probability, qubit dot get probability. In order to measure, qubit dot measure. Control shift F. Line by line we have analyzed, and these are all the what org dot red of extra strange import statement required for this statement. Let me clear. Yeah, now see I am using Eclipse. This is the process to run Eclipse. The output we are getting. See what is that? It is 0. Why? Control qubit is going to be 0. So that's why target is going to be what? Whatever it is there, it is not flipped. So C naught example using strange. Now the same C naught, and we are what changing the control qubits value. So what I am doing for that, I am adding Pauli X. In initial step what I am doing, so I have named it as initial for that I am adding Pauli X. So what Pauli X will does, Pauli X will flip the input to what 1. Now what is that? Control qubits value is going to be what? 1 comma 1. What is that? Now what we are going to do? Implementing C naught. The remaining procedures are same. Qubits dot measure. Now look at here. Begin and end. Clear. Let me clear. Lengthier program. So we should answer. So we should ensure all the lines are executed. See in this code I have not used the renderer. So we will not get circuit. If there is circuit, it will be what? It will print the simply I have ensuring all the lines are executed. Runs as Java application. Begins, ends. This dot error. Let me remove R by O U T. Control Shift F. Qubit state is 1. Now it is flipped to 1. So this is the implementation of C naught using strange. Right. Now we will little bit increasing the program complexity to have what? Applying superposition. Applying superposition. So in the code we have seen what? 10,000 experiments. We have done 10,000 experiments. So what? Listen, we had a final level variable initialized to value 10,000. Then, as usual, simple quantum execution environment program 2 qubits step. And how we are able to achieve superposition by having Hadamard gates. If we apply superposition, sorry, if we apply Hadamard gate, what will happen? We are able to achieve equal superposition. We will able to achieve. So what is the experiment? It is I am tossing coin 10,000 times in a combination of coin A and coin B. So if it is coin A, measure and it is kept in 1. If it is coin B, if it is measured, it will be given to 1 specific qubit. So it is coin A and coin B. So QEE program step Hadamard. Let me clear the console. And what qubit 0, qubit 1, I am keeping the coin types boolean because what either true or false. If not coin A, not coin B, it will be 1. If not coin A and coin B, not both, not coin A, coin B, 1. Coin A, not coin B, 1 type. Coin A and coin B will be 4 type. So I am specifying number of experiments and how it is happened. So here visualizing part renderer dot. This is for showing probability. Earlier we have print circuit. Along with the circuit, I am showing the probability. Control A, Control Shift F. I have cleared the console. Now we will get what and what. So because we have private variable 10,000. Yeah. Look at here. Let us decode the circuit later. We did 10,000 experiments. 0 occurred 2,552 times. 0 1 occurred 2,507. 1 0 occurred 2,481. 1 1 occurred 2,460 times. And this is the circuit responsible for that circuit and the probability. For 2 qubits, we applied Hadamard 50%, 50%, and the probability distribution of each occurrences 0 0, 2500, 0 1, and there is a slight, and 1 0 there is slight, and 1 1 slight. Right. So this is one simple applications we have what applied superposition using strange. So I think we have seen a small and we will explore quantum key distribution. We will explore quantum key distribution. Let me close all the earlier open the programs. Right. So random. So this is another thing. In the programming perspective, we are saying random number. Actually, it is a pseudo random number. Only with the help of quantum hardware, we can have pure random number. So actually, what is this? In a programmer perspective, we can say random number, but purely this is random number predictable by the program compiler. right? So I am randomizing simple quantum execution environment program. So size depends on what, how much we are preferring. So 4. So there is message sent 4 times and message received 4 times. So that's what user defined category it is. Then if it is acknowledged successful or not successful, sender bit as well as receiver bit, alias bits and bob bits. So there I was showing the PPT. Do you remember? Alias side section separately, bob side separately, right? See, the coding process and all same. The only difference is what we are using qubits or rather classical bits, and we are using quantum gates. Add gate, which one you are using? Pauli X, and we are measuring whatever it is there inside, that is measured. So program add step. So this is what measuring part of alias, initializing, processing, measuring alias side. Then receiver side, again bob and bob's bit will comes into picture and their index, whatever alias sent, received by bob received, and their index 1 or 0. So this line is to show the circuit which is responsible for secure communication using QKD. So BB4 protocol is used. What is it? To implement and mimic the behavior of QKD. Internally, what is that? This program is maybe API is belongs to Java. It is exactly BB4 protocol. So this is what quantum QKD sample code. Sorry, not sample code. The code for strange run as Java application. Secure communication using alias sent 0, Bob received 0. Alias sent 0 and Bob received 0. Alias sent 1, Bob received 1. Alias sent 1, Bob received 1. So time by time, these values and zeros will be what? Will be different. Let me to clear the sequence. Let me check and run once again. I will show you the final. Yeah. Now look at here. We will see the circuit. Alias send 0 0. Alias sent 1 1. Alias 0. Bob 0. Alias sent 1. Bob received 1. So this is the present circuit which is responsible for what? State 0 and what is this? Measured, and Pauli X measured and X measured, off on. Simple, exactly we are mimicking the quantum key distribution. So simple. So far we have seen what? Single qubit, multi-qubit, a simple application to have the strength of superposition and QQD. We have some program for disk check and Hadamard also, but the thing is what? We should have the configure. You can use either Maven or Gradle. So it's up to your sophistication or comfort. If you are familiar, you can use Maven. If you are Gradle, you can use Gradle. See, in chat, they are asking, no, we are not trying to prove that Strange is going to be better than the packages. This is not a package comparison. So this is to see, we are learning a new methodology. At the stretch, we are learning so many new things, it will become complicated. Somebody is confident in C programming, somebody is confident in C++, somebody is confident in Java, somebody is confident in Python, right? So this timing will be what consumed and minimized. So somebody is already aware of Java programming. They should know, they should explore only what quantum path, and the simple extra effort will take put them into quantum environment by using strange. That is the objective. So with the help of this, what is not the limitations of strange packages is It is not included. Machine learning tools packages are as of now not included. It is under development. It is under test and in development. So these are all the things already tested. So SHAR algorithm implemented, tested, quantum Q, time series analysis and all you can able to implement. So that is the objective. So if you are a computing enthusiast, if you are interested in quantum computing, you can explore in any way. You can go behind the Q sharp, Python, Java, so and so. See, and I want to stress a point here. C++, C programming, Java is universally tested and it is a well-tested programming. These three are well-tested and it is a proper programming language. No, I'm not discouraging the Python and all. If it is comes to testing, Python is less rigorously tested comparatively C, C++, and Java. So this is the thing about strange package which is available in Java programming to explore quantum computing. So let us go to chat. Yeah, frameworks and using land quantum hardware. Yeah, this is to answer those questions. So suppose somebody is already aware Java, they can continue their learning process through Java. And we are not reinventing anything. It is available. This API is already available. We can make use of these APIs. Yeah, the PPT is sample code, whichever is required that I will share with the Mr. Professor and they will share with you. And it was a great time to have with you people. So let us stop here and let me conclude before stopping the presentation. Let me conclude. So strange effects and Apache Maven integration, configuring pom.xml, so dependencies as well as plugins. So configuring their path and Maven installation verification, creating a Maven project. So there we need to put a stress over the selecting archetype and from where it should be fetched. So company name, your module name and snapshot version and the required dependencies and the plugins, then qubit gates, single gate and etc. Hadamard, Pauli, CNOT, swap, Toffoli, and steps in the quantum environment. QEE, program, steps and gate, steps and gate, results, measure, and visualizing the circuit. The high level program, Pauli X demo, Hadamard circuit using renderer, C0 when control is 0, C0 when control is 1, truth table of C0, so applying superposition to strengthening a mathematical problem, implementing QKD, the circuit responsible for the QKD. A reference, these materials are referred from Quantum Computing in Action by John Voss Manning publication, and the Maven materials and things from Maven was mavenapache.org. And finally, my team members Chandresh, Calvin, Gabriel, Mahendra Vishal, and the Jaikumar Vaidya Shankar. Happy quantum computing. So please keep in touch. If there is any query, I will share my credentials to the organizers. You can keep in touch with me.
Thank you so much, Dr. Satyaprakash. Actually, many of the participants, please try to understand that we need to have a flavor of multiple things, and we should not only look at only mastering one simulator. We should be in a position to think of building a simulator. So please try to understand. Earlier, maybe in computer science, if you're there, you would have been learning what is called programming languages, right? So programming languages were taught, and many languages we used to learn. So that subject used to be very boring. Many times students would say, but I would say that unless and until you know these languages, you will not be able to design a new language. So that was a shocking thing. And they never said, sir, do you think we will be able to develop a new language? I said, that is what you should be thinking, because we are not thinking, we are not doing. So I think someday we should be able to come up with our own thought process. So we should have a flavor of how things are happening. Because what we like and what we are more comfortable, we feel that is the only thing. But we should also see, here you could see how in a Java programming language, how the approach could be. And if study has to be done something like this, what are all that is involved? And somebody who actually likes Java very well, he may find it very easy for him to understand and do it. Then he may like it. So we should have a flavor. And also we want to bring in multiple languages, because we don't want, in fact, IBM also does not want that these training programs are pushing IBM tools, because Qiskit is an IBM tool, right? Hence we introduced Penny Dr. Jaikumar prepared, and then he made those presentations last time also and now also. So I think we are trying to give you a flavor of multiple things. So that was the background. I think you can do that. And if there are any questions, you please let us know. I will pass those questions to Dr. Satyaprakash. He will answer it. And thank you so much, sir, for taking your time.
Yeah, Professor, one more
Valuable.
thing I want to add.
Yeah,
Professor,
please.
I want to add one more thing. See, and I wanted to say the reality. Now the quantum computing paradigm is moving towards C++ and Rust. They don't want to stick to anything. They are purely migrating everything towards C++ and Rust.
REST API.
Rust, R-U-S-T, Rust.
RUST, yeah.
Rust. They are migrating towards C++ and Rust.
So in the coming days, you will have to think in that thought process to build those tools in C++. So I mean, it's all how the community takes us forward, right? So let us be prepared to be open, and let us try to pick up as many approaches as possible, so that for some aspects, one approach may be better. We may be able to use that, but having a flavor of an understanding of the things is very good. One good example, because we are looking at the object-oriented programming languages. Yesterday, I was in a board of studies where we were looking at object-oriented programming. I said, you teach object-oriented programming concepts and ask the students and ask the teacher also to give a flavor of C++, Java, and also Python. And let the lab be conducted in all the three languages. They were all finding it very difficult. Teacher also has to put a lot of struggle. Students will also have to put a lot of struggle. There will be a lot of confusion. Yes, out of confusion comes up new thoughts. So I think this is the first step to innovation. I think Dr. Satyaprakash sir will agree with me what I'm saying. So that is why this specific sir was brought in. He could have done a Qiskit. He is more experienced and expertise in Qiskit. But we asked him to do this because to give you a flavor. So I hope you all had a flavor. I mean, it is not that you should always start here, but you should know that there are alternatives to Qiskit and alternatives to Penny Lane. There are many approaches that we can try to take. Hope you had a good learning time. Please remember, there will be slight small changes here and there on some speakers coming back and forth. So I will send the final schedule. So Dr. Anindita madam will take the lectures on 4th and 6th. Dr. Santosh will take the lecture on 5th. On Sunday, we have a class this time. Please remember, Sunday afternoon, 2 to 4, very important. Dr. Rita Ji from IBM will be taking the session. So please be available. Saturday, it will be a 3-hour session again, like last time. Mustafizur Rahman will be taking from IBM again. So please make use of these and all these lectures. Tomorrow, the IBM educator, Anjana. Janani will be taking. She's an IBM educator. She's employed with IBM. So she will be taking. Janani will be taking. Then Jaykumar Vaidya will be taking. I think tomorrow Jaykumar will be taking, and day after tomorrow Janani will be taking. There are 2 lectures actually scheduled, but she's taking one. I will send you the final schedule. I'll send you the final schedule. So please note these changes. Anyway, 7th was initially the last working day, but now it is going to be 6th only. Please note that also. And we are extending the quiz for those who have missed today till midnight. You can take the quiz number 1, and there will be no more further extensions. Please note, try to complete by 12 o'clock midnight. Thank you so much. Thank you, Dr. Satyaprakash. Thank you, Dr. Vikas.
Professor, thank you so much. Thank you. I agree with you, and I'm really happy to be a part of your lecture series.
Thank you, sir. Quiz date, some of one person is asking. So it will be on 29th, it will start. So 29th and 30th, you can take it, right? Thank you so much. Thank you, Dr. Satyaprakash. Vikas or
Yeah.
Dr. Shivansh, anything you would like to add? I think even Jaykumar also joined, I think. Dr. Jaykumar? JK. Right. Thank you so much, sir. We'll take a break. Thank you.
Yeah.